It's again a wonderful time, and here we are going to look at some few principles that actually dictates the propagation of light in an optics fiber cable. So there are several characteristics, there are several properties, there are several parameters that actually affects transmission of light within an optical fiber cable. And mainly we are going to look at three important things here in this segment. The first one is called reflection. The second one is refraction. And the third is total internal reflection. All these three characteristics are actually affecting and dictating how light interacts with the medium, and here we are talking about fiber optics cable. What is reflection? When light interacts with the medium or surface, it bounces back from that surface. That is reflection. So for example, if I draw here a little bit, if this is our surface, and here we have a ray of light that is coming. We can call this incident ray from basic physics, and this is our normal. And we can call this our reflected ray. So we can have an angle here called the angle of incident, another angle here which we call angle of refraction. This is our normal surface. This is incident ray, while this is reflected ray. So when light bounces on a medium such as glass, which is transparent like this, we know if the glass is transparent, light passes through. But if we have a mirror, for example, where one side of the glass is covered, then light will be reflected back. A large amount of light is reflected back. And so when we talk about glass that is used in fiber optics, one of the important characteristics that are exhibited by glass when it interacts with light is a combination of reflection, refraction, and we are going to look at something called total internal reflection. So to take this idea further, this is basic physics which we all know, the principle of reflection. To take it further, let's look at refraction. Refraction is actually bending of light when it passes or travels from one medium to another. To show you clearly, if here we have an interface, let's say here we have air and here we have glass. We have air and we have glass. When light travels between two different medias, it undergoes refraction. Refraction is bending of light. So, let's say this is our incident ray here. From glass to air, light is going to bend. If we assume this is our normal, it is going to get refracted. Refracted means it is going to bend at a certain angle from the normal. So this is our incident ray. This is our refracted ray. As you can see, it is refracted. It is bent when moving from glass to air. This is refraction. So if we have two different medias, let's say we talk about air and water, and we shine light through, light is going to be refracted or it is going to bend. When we talk about glass and light, or glass and air, like what we have here, glass and air, when light moves from glass to air, or from air to glass, it must bend. So that is refraction. It changes its direction of propagation. Now, when we talk about fiber optics communication in particular, refraction is a very important phenomenon. So light is coming from glass, going towards air, it is going to bend. Refraction happens because of the variation of refractive index. There is something we call refractive index, N. So if here we have air, we can call this N1. And here we have glass, we can call this N2. N stands for refractive index. You ask yourself a question, what is refractive index? Why should I care about it? We are going to look at this in the next segment. Thank you.